University Calculus, Lesson 13. In this lesson, I give you 9 problems for you to try out. So you need to copy this page down. I need to explain these questions. For each of the following functions, find the slope of the tangent at the given point. So this is a function, which means you have a graph. And a point is given. This point is on the graph. And you draw a tangent at this point. What is the slope of that tangent? And this is the question. Now we already know that the derivative of a function is geometrically the slope of the tangent to that function or to that graph, to the curve, okay? Because a function represents a curve. So the derivative is the slope of the tangent to that curve. But if it's just a derivative, in general, the derivative is a function of x. So the value of x must be given so that your tangent has a fixed point to pass through. So for example, I give you this. Y is equal to x squared. So just for example. So this is a curve. It's a parabola, right? So this is a curve. Y equals x squared. What is the derivative? The derivative y prime is 2x. So this 2x is the slope of the tangent. But where do I draw the tangent? Where do I draw? So the x value must be given. So suppose this is 1, suppose this is 2, and so if I say at x equals 1, then x equals 1, this should be the point. Where the x value is given, then I have a point, and then I can draw a tangent. This is a tangent. What is the slope of the tangent? The slope of the tangent is 2x, and you have to substitute 1 into it. So the y prime is a function of x. Right? This is the derivative. But when x value is given, then y prime 1 is 2 times 1 is 2. Now you have a slope. The slope is 2. This tangent line drawn through this point, which is x equal to 1, the slope is 2. That's the meaning why the point is given. Okay, so I explain this question, then just look through the questions here. So for the first one, the function, which is a curve, the point is given. Now we know what it means by the slope of the tangent. We need the derivative and substitute the x value. Sometimes we need to substitute both x value and y value into it, and we get the slope. Okay, so same thing, similar. Function is given, point is given. I have the answers given there, so you can try out, see if you can get the right answer. So number 3, same thing. Function is given, point is given. So in this, except the point is not given by certain numbers, it's just a. It doesn't make any difference. The principle is the same. Function is given, point is given, function is given, point is given. The answers are here. Now this question, number 7. You are given two parabolas. This is a parabola, and this is a parabola. Let me review. How do you tell this function represents a parabola? You look at the exponent. Y is squared. X is to the power 1. If x is power 1 and y is power 2, then it's a parabola. So y has exponent 2, x has exponent 1, it's a parabola. So these two parabolas intersect each other. So let's say, so you have, this is one parabola. Okay, in general, okay, I have one parabola, and I have a second parabola. So they intersect at 2 points. Now we come to the question. Prove that the two parabolas, this and that, intersect at right angles. What does it mean by intersect at right angles? So you have points of intersection. You draw a tangent at the first point, tangent to this parabola. Okay, that should be your tangent line. Draw another tangent at the same point, but that second tangent is tangent to the second parabola, tangent to this parabola. So I need to draw like this. So you have two tangents. The tangents are just straight lines. So you have two intersecting straight lines. Therefore, you have angle of intersection. So this is the angle of intersection of the two lines. Or you can say this is the angle of intersection. It doesn't matter whether you say this is the angle of intersection or this is the angle of intersection. It doesn't matter. So this is what we mean. The angle of intersection of the two tangent lines can also be described as the angle of intersection of two parabolas. So this is the interpretation of number 7. You want to prove the angle of intersection of two parabolas. The angle of intersection is right angle, is 90 degrees. That means you want to draw two tangents, and the angle between the two straight lines is 90 degrees. That's what you want to prove. So how do you prove the angle if you have two tangent lines? Then we need a formula. If you have two straight lines, the slope of this line is m1, the slope of this line is m2. Then what is the angle? Then you need this formula. Tangent theta is equal to m2 minus m1, 1 plus m1 times m2. You have this formula in previous lessons. Okay, so let's see now. Okay, so you have this formula before. So use this formula to find the tangent theta. Once you have the tangent theta, you can find the theta. That's how you do it. So you need the slope. Go back to this. You need the slope of this parabola, and you need the slope of this parabola. Once you have the slope, m1, m2, then you use the formula, you get the angle of intersection. Next problem. Prove that this circle and this circle are tangent to each other at this point. Now, first of all, in the last problem, problem 7, I have explained how do you find out that it's a parabola. So y is exponent 2, x is exponent 1. It's a parabola. How do you know it is a circle? So y is to the exponent 2, and x is also to the exponent 2. So in other words, if x and y are both have exponent 2, then it is a circle. So we want to prove that this circle and that circle tangent to each other. What does that mean? You have two circles. So these two circles intersect at 2 points. So they are not tangent to each other. What does it mean by two circles tangent to each other? So if you have a geometry like this, then it is this circle and this circle, they are tangent to each other. Tangent. That means they only have one point of intersection. Here, if they intersect, they have 2 points of intersection. If they have only one point of intersection, they are tangent. How do we prove these two circles are tangent to each other? Look, you have only one point of intersection. You draw a tangent line through this common point. Draw a tangent line. Look at this diagram. This tangent line is tangent to this circle, and this tangent line is also tangent to the second circle. This is how you prove it. This is how you prove two circles are tangent to each other. So, find the point of intersection. You need the point of intersection, but you don't need to find it because it's given. 2, 1, that's a point of intersection. So, find slope of the tangent to this graph, to this circle, at this point. Find the slope of the tangent to this graph, to this circle, at the same point. If the slopes are the same, then you get only one tangent line, which means this circle and that circle are tangent to each other. Next question. At what angle does this line cut the curve? Now this is not a circle. Oh yes, this is not a circle. Okay, I should say more about how to find it is a circle. So I'll go back to question 8. This is a circle, and I said you must have a square here, and you have a square here, and also you have one here and one there. That means it's a circle. Now here, you have a square here, but you have a 1 here and a 2 there. So it is not a circle anymore, but it's a graph. Well, it doesn't matter what kind of graph it is. You have a line and a graph. So you have a line and a graph. The graph will be something like that. And then you want to find what is the angle. What is the angle here? So you need to find the point first. Find the point of intersection. So if you have 2 points, then you find the 2 points of intersection, and then you draw the tangent line to this graph. You don't need another tangent line for this graph because it is a straight line. So what does it mean by find the angle? You want to find this angle, either this angle or this angle. That's what you are going to find. At what angle? So what do you do? How do you do? It is still use this formula. Tangent theta is equal to m2 minus m1, 1 plus m2, m1. It is still this. So since the straight line is given, so you know m1 And you draw a tangent to this graph, you have M2, and just use this formula to find the angle between them. So this is the analysis of this problem set. So for 7, 8, 9, I don't have the answer here. But the answer here is to prove, so you don't need the answer. To prove the angle of intersection is 90 degrees. This is to prove that you have two tangent lines, tangent to this and tangent to that at this point, and you only want to prove the tangent line has the same slope. The two tangent lines have the same slope. That's how you prove. But this, you need angle, so I don't have the angle yet. So, all right. But anyway, in the next lesson, lesson 14, I will give you the solution of the answers. Or not all the answers. I'll give you the solution to all the questions. Okay? So right now, you need to copy this, the 9 questions. And that's all for this lesson. But I need to explain something. Maybe you have some difficulties here or there. Or you have some difficulties of the previous lessons. It doesn't matter whether you understand the lecture or not. If you have any questions, so this is my this is what I want to tell you. So if you have any questions about the lessons, or you have any questions about the practice problems, please send me a text message. This is my phone number. Send me a text message and tell me what your problem is. Or if you don't send a text message, you can send your question to my email address here. And I said it is best to have a picture. You take a picture of your work. How do you do the work? How do you do the problems, but you get the wrong answer? Send me a picture, and I will tell you what's wrong with your answer, what's wrong with your wrong answer, or we will discuss any questions associated with the question or associated with my lessons. That's my announcement. Okay. This is lesson 13. Thank you for watching. And wait until I give you lesson 14, the solution part. Goodbye.